In this question, we have a variable force F equal to Cx minus 3x squared acting on a particle that moves along the x-axis. The force is in Newton, x is in meters, and c is a constant. At x equal to 0 meters, the particle's kinetic energy is 22 joules, while at x equal to 4 meters, its kinetic energy is 11 joules. The question requires us to find the constant c. We all know that mechanical energy of a particle or a body is given by this expression. Final mechanical energy is given by the initial mechanical energy plus or minus the work done. It is a plus if work is done to the particle or the body, and it's a minus if the work is done by the particle or the body. In this case, the work is done to the particle by this force, variable force that is acting on it. One other expression or equation we need here is an equation for work done. Since we have a variable force in this case, the work done is given by the integral of force F with respect to x. Because the force is changing with changes in position x, the expression is given as an integral, not just a direct multiplication. So, work done on the particle from position 0 to 4 will be given by the integral from x equal to 0 to x equal to 4. So by substituting this into the earlier expression we have up here, we have our final mechanical energy equal to our initial mechanical energy plus integral x from 0 to x equal to 4 f dx. Now in this case, the only mechanical energy we have is kinetic. So we can further break this expression down to kinetic energy final is equal to kinetic energy initial plus integral from x equal to 0 to x equal to 4 f dx, where f is a function of x. Going back to the question, we see that our initial kinetic energy, Ke initial, is equal to the kinetic energy at x equal to 0, which is given by 22 joules, right? And the final kinetic energy is at the final position, which is equal to kinetic energy at x equal to 4, which is the final position, and that gives us 11 joules. So we're going to substitute all this into the expression we have. By so doing, we would have that 11 is equal to 22 plus integral from x equal to 0 to x equal to 4, f being cx minus 3x squared dx. Okay, so we have this. I can take this to the other side, the 22, by subtracting 22 from both sides. So the left hand side will equal negative 11 equal to integral from x equal to 0 to x equal to 4 cx minus 3x squared dx. So I'm gonna do the integration now. We have minus 11 is equal to cx squared over 2 minus, it's gonna be 3x squared, sorry, cube over 3. And then we substitute from 4 to 0. This will give us minus 11 equal to, I can further break this down to cx squared over 2 minus x cubed, and then we can now carry on with the substitution. If we substitute 0 into the expression, the integration we did, everything will be 0. So we'll just go ahead and do the substitute just the 4. So we have c 4 squared over 2 here minus 4 to the third. And like I said, if you substitute 0 in here, you have c 0 squared over 2 minus 0 to the third. Further simplification will give us minus 11 equal to this. 4 squared is 16, divided by 2 is 8, so we have 8c. And then 4 cubed is the same thing as 16 times 4, which will give me 64. And then minus 0, doesn't matter. We can add 64 to both sides, and this will give us 53 on the left hand side is equal to 8c. By dividing both sides by 8, we arrive at c equal to, we can just leave it as 53 over 8. And what is the unit of c? If you go back to the expression for f, we see that f is in Newton. So cx is in Newton, right? Because every time, so cx is in Newton, 3x squared is also in Newton. So if we have that cx is having a unit of Newton and x is having a unit of meters, that implies that c must have a unit of Newton per meter, so that the product of c and x will return you back to Newton. Therefore, c is 53 over 8 Newton per meter. Thanks for watching.